Hi students, this is Ali and you are in module named as Early Exploit Hardening. This module is the part of Windows System Security Hardening course. So let's start. It's important to understand the boot process before going to secure the Windows 10 boot process, because it provides several key pieces of forensic information and allows you, as a forensic examiner, to control the boot process to use forensic booting tools. Even if you are a student, it is very much important to understand the boot process before going to secure boot process. Let's take a look at what happens when you boot a computer. When you turn on your computer, the power supply sends power to the motherboard, which in turn activates the boot process. Power on self-test post instructions are stored in a ROM read-only memory chip as part of the BIOS or the basic input-output system. The post runs through a series of tests to make sure everything is working. Most post sequences will have a combination of audible and visual messages to let you know what is and isn't working. These are the beeps that you generally hear when your computer is booting up. The post checks your video card. At that point you will see information from the post on the screen. The post then checks to make sure it can find a CPU, and that is communicating. Then it tests your RAM. This is a very basic check of whether it can communicate with your RAM. Now it checks for keyboard and mouse depending upon the type of keyboard you have. You might see the keyboard slide splash. At this point you would normally see indication on the screen of how you can enter the BIOS setup program on your computer. Each BIOS software vendor will have a different keystroke, but it is often either F2, F10 or the delete key. This vendor's key is F2 and we will enter BIOS setup. This is where important forensic information is stored, including date and time information, and the booting order. Your computer can be set to boot from your hard drive first, or from your CD, or a USB drive, or even from the network. If you want to boot the computer with a forensic boot CD or forensic USB device, you may need to change the boot order. Lights on each drive will flash as the post checks them for booting instructions. Most computers are set up to check the optical drive first. This makes it easier to install new operating systems. Then they check the very first hard drive. Drive 0. Post is looking for the master boot record. The master boot record is always at cylinder 0, head 0, and sector 1. It points to the boot sector. Finally, post is done and the operating system takes over. Rootkits. Malware authors use rootkits to hide malware on your device, allowing malware to persist as long as possible. A successful rootkit can potentially remain in place for years if it is undetected. What are the threat of rootkit? Rootkits are a sophisticated and dangerous type of malware that run in kernel mode, using the same privileges as the operating system. Rootkits have the same rights as the operating system and start before it. They can completely hide themselves and other applications. Rootkits are part of an entire suite of malware that can bypass local logins, record passwords, keystrokes, transfer private files, capture cryptographic data. Now, how are types of rootkits being practiced? Types of rootkits. Firmware rootkits. These kits overwrite the firmware of the PC's basic input-output system or other hardware so the rootkit can start before Windows. Bootkits. These kits replace the operating system's bootloader, the small piece of software that starts the operating system, so that the PC loads the bootkit before the operating system. Kernel rootkits. These kits replace a portion of the operating system kernel so the rootkit can start automatically when the operating system loads. Driver rootkits. These kits pretend to be one of the trusted drivers that Windows uses to communicate with the PC hardware. What are modern malware families who use rootkits? Number 1. Aluron. Then Cut Whale. Detrahere, Zasenlo. Rustic. Sinel. And Sirefef. How to protect your system against rootkits. First, Apply the latest updates to operating systems and apps. Second, educate your employees so they can be wary of suspicious websites and emails. Last but not the least, back up important files regularly. Use the 3-2-1 rule. Keep 3 backups of your data, on 2 different storage types, and at least 1 backup off-site. By default countermeasures comes Windows 10. Secure Boot. PCs with UEFI firmware and a Trusted Platform Module, TPM, can be configured to load only trusted operating system bootloaders. Trusted Boot. Windows checks the integrity of every component of the startup process before loading it. Early Launch Anti-Malware, ELAM. ELAM tests all drivers before they load and prevents unapproved drivers from loading. Measured Boot. The PC's firmware logs the boot process, and Windows can send it to a trusted server that can objectively assess the PC's health. Secure Boot, Trusted Boot, and Measured Boot block malware at every stage or explained in the figure. Here you can see PCs with UEFI firmware and a Trusted Platform Module, TPM, can be configured to load only trusted operating system bootloaders. Secondly, Windows checks the integrity of every component of the startup process before loading it. If your Windows haven't enabled the secure booting, the Rootkit, enter in term Measured Boot and grant access to the main control. Now what if I think I have a rootkit on my device? Firstly, I strongly recommend reinstalling the operating system and security software. You should then restore your data from a backup. Lastly, if the problem persists, replace the hardware. No solution exists. It is not my recommendation to replace your system because I recommend to harden your before the problem starts.